All right, good morning, e-learners.
Hi.
One of you sounds very close today. It's like I hear your voice or something. All right, go ahead and get out your homework. Out. When you fix yourself, come back in. All right, any questions on the homework before we grade it?
No.
All right, let's talk about this quite please. Let's talk about this quickly. Where are your mistakes when you do the distributive property? Two big mistakes. Your mistakes will either be because drop a negative, right? Very common mistake. And the other one is it's just a calculation error. You do the math. Listen, please. Hey, two biggest mistakes for a distributive property are you're multiplying with a positive and negative or a negative and a negative, and you just kind of forget about that. You just look at the numbers. Oh, 2 times 6 is 12. Right? Make sure you look at the signs. And the second big mistake is, well, if it's weird numbers, you're multiplying, I don't know, 12.1 times 3.6, and you simply do a calculation error. So keep that in mind when you're doing the distributive property. Two major errors. Questions on 44 through 66. All right, let's grade this. Here we go. Hey, you guys are a bit too noisy for me today. Okay, I don't need your help. Okay, so 44, it's not the distributive property, just combining like terms. Now, I'm going to tell you one way of writing it. It can be written the other order as well, too. 44 is 7c plus 3d. 45, s plus 4t. It can also be 4t plus s. 46, 4d plus e. 47 is 6x. 48 is 5f plus 5g. 49, 4x plus 15. 50, 3n plus 1. 51, 3a minus 25. 52, 2n minus 7. 53, negative 2x plus 17. 54, negative 3y plus 20. 55, 5x plus 17. 56, 6y minus 15. 57, 12y plus 15. 58, 3n minus 27. 59, 60, this is your standard. I mean, distributive property is not an Algebra 1 thing, it's a pre-algebra thing, so now you get into where they give you three things on the inside of parentheses. So 59 is 6x plus 3y plus 3. 60, 35y minus 15z plus 20. See a bunch of people not even looking at their homework. Come on, look, show them or grade it. 61, 21a plus 17b. 62, 38k plus 83m. 63 is 11r plus 12. 64, 7n plus 13. 65, 34c plus 14d plus 50. And the last one, 20x plus 40y plus 10. All right. Count up how many you got wrong, put it on the top. Select, pass out. Where's your homework? All right, everybody look at the calendar. Look at the calendar. Quiet, please. Got a quiz tomorrow. So let's talk about the quiz. Talk about the quiz. Hey, time out. Time out. Time out. You guys keep doing what you're doing. Do it quietly. Hey, attention is horrible today. All right, quiz tomorrow. Let's see. 2.1. Somebody open the book. What do we do in 2.1? What do we do in 2.1? Somebody open up their book. What was section 2.1?
Just the different properties.
Properties. I would have a resource card if you cannot tell me the difference between the associative property, the commutative property, the property of the multiplicative property of 1, the additive property of 0. Right? If you can't tell me those properties off the top of your head and just look at something and say, yeah, that's the associative property. Right? Associative property order stays the same, the parentheses move. Commutative property, hey, the order changes. If you can't tell me that 5 times 1 equals 5 is an example of the multiplicative property of 1, anything times 1 is itself. If those aren't in your brain right now, it needs to be on a resource card for tomorrow. There will be, I think, 3 or 4 questions. Just name the property. Okay? 2.2, what is it? 2.2, what do we do? Okay, we didn't do 2.2. We skipped 2.2 because I didn't like it. So we immediately went to 2.3, which was? Are you paying attention? 2.3 was? I believe it was adding integers, right? Do you know how to add positive and negative numbers? In other words, adding integers. Okay. 2.4 was subtracting integers. Do you know how to subtract integers? Then we went to the last ones, which were 2.5, 2.6, which was combined like terms and the distributive property. So let's see. What am I going to ask you? I'm going to ask you 3 questions. I think it's 3. It might be 4. On properties. I literally just told you the answers. Associative, commutative, and it's either the property of 1 or the property of 0. What's the property of 0 say? What's the property of 0 say?
Anything times 0 is 0.
Anything times 0 is 0, and anything
Plus 0 is itself.
is itself. That's the property of 0. What's the property of 1?
Anything times 1 is itself.
Anything times 1 is itself. Right? In my mind, that's not a challenging thing. In your mind, it might be because you don't, I mean, not the property of 0 and property 1, but maybe the associative commutative. So on a resource card, copy down the examples from the book in section 2.1 for associative and commutative property. Hopefully you don't forget about the property of 0 and property 1 because those are the simple ones. Distributive property, what we just did was, okay, towards 66, those were challenging. Some of the, I'm not going to ask you a super challenging one. It's going to be, can you use the distributive property? Certainly, I'm going to throw some negative numbers in there because we want to make sure that you can do it with positive and negative numbers. Okay, that's the quiz. Any question? All right. We will at least, even if we had a 2-hour, I don't think we're going to have a 2-hour delay. It's too warm out there. But even if we have a 2-hour delay, we will do the quiz tomorrow. All right, here's your homework. Copy it down. What? Okay, no pencils. You need to bring pencils to class. Right? You have worn out my generosity for pencils. Yes? No, we're going to do something crazy complicated that you've never done before and that it requires a math teacher to cheat. No, we're just doing that. Yes, you're right. All right, need you to take the jacket off. Everyone else in uniform? Yes, we are. Good job. All right, so Ryland, thank you, already spoiled the fun and said, wait, is the only thing we're doing is multiplying, dividing today? Yeah, that's all we're doing today. All right, now, just be careful because there's some people in class that their problem isn't the rules, their problem is literally the multiplication and division. So maybe this is a good chance for some of you that are weak in that area to make a concentrated effort of doing the procedure correct. No, we're not doing long division today, but certainly some of you might need some extra work on how to multiply a 2-digit times a 2-digit. But no, the actual math is entitled multiplying with integers and dividing with integers. And yeah, some of you know that. Now, if you multiply 26 numbers together, could you tell me if the answer is positive or negative just by looking at the question? If I gave you 26 numbers to multiply together, could you tell me if the answer was positive or negative just by looking at the question?
Yes.
Okay, that would be the other thing that I'm going to show you today. Okay. So it says rules for multiplication. All right, remember we're going to be doing math with integers. Those are the natural or the whole numbers, and they're opposites. There is no opposite of 0. So the natural numbers, the counting numbers, they're opposites. That would be the negative numbers, as you would think. You put those together with the number 0, we get the integers. The integers. All right. Yes, today you might see this symbol, but we're certainly not going to see it much beyond today, right? Multiplication, though, is typically written how in Algebra 1? How do we typically write multiplication in Algebra 1?
The dot.
With a dot or a parentheses. Okay, so that's generally, you might see this, but not much past today. Scientific notation would be the one rare exception. All right, just remember with parentheses, you can write it 3 different ways. You see with parentheses, the same thing, 6 times 5, but 3 different ways. All of these, all 5 of those simply mean 6 times 5. All right. With negatives, you can kind of see the reason we might write it with parentheses and not a dot. With the dot, with a negative, it looks kind of weird. So almost universally, when we multiply with negative numbers, the parentheses is the preferred choice for showing multiplication. Okay? Obviously, without the parentheses, it looks like 6 minus 5. Even with the dot, because the dot kind of blends in with the minus sign, it might look like 6 minus 5. With parentheses, you're not going to mistake it for subtraction. All right, but just like with parentheses, negative can be written, what, 3 different ways. I'm not claiming here that the answer is the same number, but I am saying that this is how you would see it with the subtraction symbol or the negative number or the negative indicator of the number written. All right, hopefully I didn't confuse. I'm not claiming this top line here that's not yellow. All those are 30. This bottom number, that's not the case for this. 2 of these are the same answer. 1 of them is different. All right, Rylan, if you can tell me why and prove to the class a negative times a negative is a positive, you don't have homework. Why is a negative times a negative a positive?
Why is a negative times a negative positive?
I mean, this. Let's be honest, right? That is the one question that doesn't make sense. What's a negative plus a negative?
Asking me?
Yeah, what's a negative plus a negative? Always. What's a negative plus a negative?
Positive.
It's never a positive.
Never a positive. I'm thinking of times it's fine.
What's a negative plus a negative? Everybody else. It's always negative. There is no negative number that when you add another negative, you ever get positive. There's no number that exists. And the reason why I asked Ryan, because it's probably the only thing I might show you today, is that multiplication is just repeated addition. Think about that. If I repeatedly add a negative number, I just mark further down the negative number line. All right. Add another negative 5. I move 5 in this direction. Add another negative 5. I'm just getting further and further negatives. We know that multiplication is repeated addition. So you would think that a negative times a negative would give you a big negative number if it's just repeated addition. And the issue is that a negative times a negative is a positive. So if there's one thing that I will claim that I will teach you today is to show you why a negative times a negative is a positive. Others of you may say, I don't even know why a negative times a positive is a negative. Why does that work? I'll show you that as well too. However, you guys have all claimed that you already know this. Yes?
Yes.
Some of you have asked and you have told me. Nathan, what's the rule for multiplying with positive and negative numbers? What's the rule for multiplying positive and negative numbers? Like, how do you know the answer is positive or negative? What's 2 times 3? What's negative 2 times 3? Okay, so do you know the rules?
Yeah.
Well, then tell me the rules.
9 times. What?
Okay, don't distract him.
I need to write this.
Okay, so you don't know the rules. Porter, what are the rules for multiplying positive and negative numbers? Porter doesn't know the rules. You know the rules? Do I need to call on anyone else?
Okay, so
All right.
I get the rules, but like,
So I didn't choose those 3 people to call out. I just chose some people that were kind of looking in my direction, right? You know the rules? What are the rules?
A positive times a positive is a positive. A negative times a negative is a positive. A negative times a positive is a negative, and positive times negative is negative.
I would bet that half the class could do that, yes?
yeah.
The other half of class, well, I just picked 3 at random. They couldn't even do that, right? So for most of the class, right, we probably need to write this down. For those of you that already know the rule, why is a negative times a negative a positive? I don't know, because my math teacher told me. So my goal here is for the 2 groups of people. For the people that could not, and that was well done, that can't tell me the rules, I'm going to show you why it's the case. So that you don't walk out of here saying, I still don't know why a negative times a negative is positive. For those of you that do not know the rules, you're going to write the rules down and learn them today. Clearly, she doesn't need to write the rules down because she just told me the rules. But what she can't tell me, nor could Rylan, which is why a negative times a negative is a positive.
Actually, you didn't give me a chance to answer.
You got 10 seconds. Go.
That's like, oh, well, you can't just add 2 names. Like, you can't, like, like, why would you put
What's the answer?
8?
Yeah. Why do you know the answer is 8? Because repeated addition is multiplication, right? So if all of these were negative, what's the answer? Why is this one negative, but multiplication it's positive? That doesn't make any sense. Repeated addition is just multiplication, 2 times 4. But all of a sudden the rule, it seemingly changes as soon as we change this to multiplication, because both of you are claiming that a negative times a negative is a positive. If multiplication is repeated addition, we should be a negative number. There must be some, by the way, I'm going to tell you the answer. That's the issue that I'm trying to describe why I need to explain this. Because intuitively, it doesn't make sense that a negative times a negative is a positive. If repeated addition of negative numbers only results in a negative number, -8, you would think that a negative times a negative should be a negative. All right. So I've defined the problem. Now let's see if I can answer it. Before we do that, though, let's write the rules. She literally said, what did she say? She said a positive times a positive is a positive, and then what was the next thing she said?
A negative times a negative is a negative.
We're going to call those same signs, right? Remember when we talked about adding, subtracting, we talked about same and different signs? When you are multiplying, same signs. That means a positive times a positive, or a negative times a negative. She said the answer was, and that's the right answer, but it doesn't answer the question why. It doesn't make sense. Further, she said, what was the next rule? She said,
A positive times a negative.
she said a positive times a negative. We'll call these opposite signs. She said a positive times a negative or a negative times a positive is, if you don't have this memorized like she did, right, and most of you I would claim probably do, you need to write this down. Notice I don't have a box for it. I expect people to walk in that I've taught pre-algebra to know this. Thank you, Porter, for forgetting this. You did this last year, right? You have someone sticking up for you. Okay, big boy, big girl stuff. Yeah, I guess maybe 2 years. You better have it memorized after this year. Can we agree on that? Okay. All right. Does everyone who needs to have this rule written down? Because I'm moving on. All right. I'm going to answer the why question. Why is this the case? All of those. All right. If you remember, the first time you learned multiplication, if you can remember way back when, 3rd, 4th grade, right? Your teacher probably showed you this. She gave you a problem like 2 times, say girl, could have been a man, 2 times 3, what did he or she draw? What? They didn't just say the answer was 6. How did they explain it? Correct, right? We use this grouping method. And we said that 2 times 3 can be interpreted as, go ahead, give me your thought. 2 times 3 could be interpreted as 2 groups of 3, right? Literally, they probably said 2 times 3 is 2 groups of 3, and they drew cookies. I don't know, right? But they drew something to represent 2 groups, 1, 2 of 3. And then they said, count them up. How many we got? We got 6. And that's how they explain multiplication. If that's how they explain multiplication, it should work for all of these. Well, let's see if it works. What does this say? Well, use this phrase, though. This is 2 groups of, how do we draw negatives? All right, so this is 2 groups of -3. So how many do we have here? We have 6 of these things, but they're with a negative sign. Therefore, that's why the answer is -6. So I just explained to you why a positive times a negative is a negative. Okay? This one I have 2. Now I could just, multiplication is commutative. I can move it around. So this would be 3 groups of -2. I'm going to choose a different way. Right? What is the opposite of 2? Okay. So I'm going to say that this is the opposite of, keep reading, 2 groups of 3. So instead of saying -2 times 3, you just told me -2 is the opposite of 2. So I'm going to say the opposite of 2 groups of 3. Well, what was 2 groups of 3? So therefore, what's the opposite of 6? This is why a negative, right? The opposite of 6 is -6, right? This is why negative times a positive. So why is a negative times a negative a positive? It comes from this. All the same pattern. How did I read this?
2 groups of 3.
I didn't say 2 groups of 3. What did I say?
The opposite of
I said the opposite of 2 groups of 3. So this is the opposite of 2 groups of, well, what was 2 groups of -3? What's the opposite of -6? That's why a negative times a negative is a positive. This is hard to accept. It doesn't make sense because multiplication is repeated addition. If I repeatedly add -2, I never get to a positive number. But through multiplication, I do. Only when it's a negative times a negative. So a negative times a negative, the opposite of 2 groups of -3. Here's 2 groups of -3. Well, that's -6. And the opposite of 2 groups of 3 will be the opposite of -6. The opposite of -6 is 6. Negative times a negative is a positive. And that's why this works. So most math teachers stop with what she said, and they're like, wow, they got all the rules. They never explain the why it works. There I did. All right. So everyone that has the rules has them written down, correct? Sorry. Yes? We good? All right. So these are not the rules for addition and subtraction. Occasionally, I will get students that get confused. I don't get confused by these rules right here. They're simple. But then all of a sudden, tomorrow, quiz, I give you a quiz where you have to add and subtract, and you think you're multiplying. We're not multiplying. We're adding and subtracting. Follow those rules, which you guys have already shown me you know what you're doing. Yeah. We'll talk about that. Good one. We'll talk about that. You said, what happens if we have 3 negatives? We'll talk about that. All right. So let's do the easy ones first. This is pre-algebra. Hey, what's a positive times a negative? Therefore, the answer is? Hey, what's a negative times a negative? Therefore, the answer is? Here we go, box 2 real quick. What's a negative times a positive? So therefore, the answer is? Are you doing this? Grab your pencils. What's a positive times a negative? Therefore, the answer is negative. What's a positive times a positive? Therefore, the answer is You don't have to put plus 130. Let me catch up with you, sorry. What's a negative times a negative? Therefore, the answer is, all right, you've just now completed last year's work. That's where we stopped last year. We okay? We will do, and I had 4 more in case we needed them. Do we need 4 more? Okay. So last year you were, well, it should have been 2 years ago, but certainly in pre-algebra you're expected to master this stuff, right? Today's not necessarily a class on how you do this multiplication. It's a little bit more than that. One, I need to explain why negative times a negative is a positive, or positive times a negative is a negative. And then Julie's question, what happens if you have more than 1 or more than 2 numbers being multiplied together? What happens? All right, for those of you who did it, there's the answers. So here we go. We learned when we did PEMDAS that how many numbers can you multiply together at once?
Sure.
Right? Turns out that you can add how many numbers at once? Lots. You just stack them and you add. But when you do multiplication, you can only multiply 2 numbers at a time. And you also must go in what order?
Left to right.
Unless there's only multiplication in which you can multiply them in any order. Okay? But if there's more than just multiplication, you have to go left to right. For me, even though I know that this is commutative and I can multiply them in any order, I just go left to right. And that way I don't have to worry about, oh, well, sometimes I can multiply in any order. I just always go left to right, right? And that way I don't have to worry about the commutative property. So let's see if we can, and this was the question I asked Riley. I said, if I gave you 26 numbers, could you tell whether the answer was positive or negative just by looking at it? So let's see if Nathan can do this. Nathan, what's a positive times a negative? Times a negative. Okay, one more time. What's a positive times a negative? Times a negative. So can you tell whether the answer is positive or negative just by looking at the question? Rylan, is that an efficient method, what I just did with him? He said no. What would be the more efficient method? Okay, well, you got to tell me what you're doing. If I said, I just look at it.
Well, I don't know the numbers specifically, what it has in front of it.
So what I just did with him is different from what you do?
No, you just did slow.
Okay. Now I'm going to write 100 of these. Is that method efficient? What's a positive times a negative? Times a negative, times a positive, times a negative, 100 times. Is that efficient? Is there a more efficient method? Landon?
You group the negatives, so it turns into a positive, and then you multiply the positives.
What do you mean group the negatives?
You multiply the negatives, so it cancels out and turns into.
Yeah, but what do you mean group them?
Put all the negatives together.
If I put all the negatives together, would you necessarily get a negative or a positive?
Positive.
Well, how would you know? Because remember, a negative times a negative is a positive. Times a third negative would be negative. So how do you know whether you're going to be positive or negative?
Depending on how many positives you have.
Okay, I like where you're going, but you got to think that one through. What do you mean depending upon? Well, I think you're closer, but not even numbers.
No, but like even amount of like.
Oh.
Amount of negatives or
Why would an even amount of negatives be important?
even amount means that it's a positive and a negative amount is negative.
Think about this. What's any 2 negative numbers multiplied together? What's any 2 negative numbers multiplied together? What's any 2 negative numbers multiplied together? What Rylan said and what Landon said as well too is like, if we could group them in some way, pairing them up. In other words, if you have an even number of negative numbers, the answer is always, if you have an odd number, the answer must always be, because you always have that one extra negative that makes the whole thing negative. I have 62 negative numbers. When I multiply them together, that's a positive. But if I have 63, that last negative kicks the whole thing negative. All right, did that make sense? Today, or I should say this year in algebra, the way that you keep from making a silly mistake is you just count how many negatives you have. I got 2 of them, therefore the answer is, if I had 3 of them, the answer would be, so if you have an even number of negatives, the answer is always. You're like, wait, what about the positive numbers? Well, remember, positive times a positive is always positive. I don't need to worry about the positive ones. I only need to worry about the negative ones to tell me whether the answer is negative or positive. Because think about it. If I do give you 4 numbers, which I will, to multiply together, do you want to mess around with the negatives or positive, or you just want to write the answer? Well, I know the answer is negative or positive, and then scratch work, multiply the numbers together. It's a little bit more efficient to multiply the numbers together and then to assign whether it's positive or negative. So that's the idea. So the 2 issues, remember, were, is the answer positive or negative, and then what order? Well, we just answered both of those. The order, if it's just multiplication, that's whatever floats your boat. Is there any mixture of addition, subtraction, or division with it, you got to follow PEMDAS, left to right. The positive or negative, we just answered that. So do you need to write that down? How about we do that? Box 4. So whether it's positive or negative, right, to determine the sign, an even number of negatives means the answer is positive. Hey, there's 4 of them, the answer is positive. Hey, there's 12. Hopefully I never give you 12 numbers to multiply. Hey, I should see a pencil moving somewhere. But if there's an odd number, the answer is negative. Now I don't need to worry about it. I can just concentrate on multiplying the numbers together. I know the answer is either positive. Oh, by the way, the answer positive or negative here. It's positive. Now I just need to multiply 4 times 6 times 7. The answer to what order, right? Depends. If there's just multiplication, you can commute. If there's any adding, subtracting, or division involved, then you have to follow PEMDAS. When I look at 4, 6, 7, I can't think that there's an easy way to multiply those together. That one's you just got to do the multiplication. Some might argue, well, 7 times 6 is 42. That's easier to multiply times 4 than 24 times 7. Okay, I'll buy that as well. But the reality is it's still multiplying 3 numbers together. Who's lost? If you have an odd number, the answer is negative. If you have an even number, you're literally just counting negatives. If it's even, the answer is positive. If it's odd, the answer is negative. So this would be the Algebra 1 skill, not the negative times a negative is a positive. Am I okay to move on?
Yep.
All right, is the answer going to be positive or negative? Tristan? How do you know? Count how many negatives. Is 2 even or odd? Which one? You said both. Okay.
Even, sorry.
For those of you that need to write this down, what's the difference between an even and an odd number?
Their size or
What's the difference between an even and an odd number? Go.
standing.
Okay. Well, then you got to do some division. You want to know an easier way to remember if it's an even or not? He's right. And by the way, every math book in the world would say that. I've said that. I've chosen now to not say an even number is that for some students. You want to know an even number? That's the last digit. If you see a 0, 2, 4, 6, or 8, it's even. Right? I don't care what the other numbers are. It can be a 40-digit number, but if it ends in 0, 2, 4, 6, 8, it's even. If it ends in a
5.
give me them all.
1, 2, 2.
2's right there.
1, 3, 5. Yeah.
Then it's odd. Oh, by the way, these are the numbers that are divisible by 2. All right. For those that were too scared to ask what's an odd or even number.
I'm sorry.
All right. Therefore, since there are 2 of them, it ends in a 2, it's even. It's a positive number. Now I just got to do the math. All right. Smarter person than me, tell me the order you'd multiply them.
Left to right.
She said left to right. She's not even going to mess with it. Is there a better way for this one? If you spend more than 5 seconds thinking about this, go left to right. Don't spend more than 5 seconds. Go, bro. So the question was, is there a better way? She goes, let's just multiply them left to right. And I said, well, yeah, maybe there's a smarter way, but if you spend more than 5 seconds thinking of that smarter way, then she's already at the answer, right? Was there a better way of multiplying this? I would leave the 10 off until the very end. Because then you just add a 0.
Yeah.
Right? But once again, I'm kind of with her. A lot of times you spend this, whoa, let me think of the perfect way of doing this, and she's already been at the answer 30 seconds ago. So give it a 5-second rule, right? Go ahead, Tristan. What's the answer, positive or negative?
Positive.
Count how many negatives?
3.
Does 3 end in a 0, 2, 4, 6, or 8? Then it's negative. All right. Anybody want to take a shot at the easy way to multiply? Anybody? Left or right, or pick and choose?
You did it 3 times 9 times 2.
Notice I got 10 right here. Leave that for the end. 9 times 3 is
27.
times 10.
10 times 30.
And we just agreed that the answer was what, positive or negative? Okay, so maybe this one, and it'll take me 1 or 5 seconds to see that. Maybe this one I might not go left or right. I'm saying you go left or right here, it's some work, right? So it's certainly worth a look, but not more than 5 seconds. Did that make sense? Like, I don't want you to spend 30 seconds trying to figure out, well, what's the best way to multiply when you could be done in 30 seconds. All right, do box 5 all by yourself. Do box 5 all by yourself. Shame on you if you can't tell me whether the answer is positive or negative, right? If you need to write it on a piece of paper, Tristan, grab your pencil, get to work. Are you confident your answer is right? That it's positive or negative? You only did one of them, by the way. You should be confident that you can tell me whether it's positive or negative. The actual multiplication, all right, you know, you might mess that part up, but you better know whether it's positive or negative. Who's lost? Positive or negative? So put equals negative. Equals negative. Now do the math. And then you can at least be assured that you got half of it right. Nathan, you good? Okay. Aiden, yay, nay? Chris, yay, nay? Yay or nay? You got this? Okay. Piper, yes, no? Board over. Don't give away all the secrets. Well, the difference is I didn't get to see your face because I had to. Now I can see your face and I can tell whether or not you got it or not.
Well, it's pretty obvious in board is crap right now.
So we're half the people in here, myself included.
Is it because it's us?
No.
I feel like
Well, no. There's a lot more fun things to teach than this.
Okay.
Right?
Oh, definitely. Are we allowed
I want you to try it by yourself, but I also don't want you to spend 20 minutes on it, right? So multiplication table is what I would suggest. All right, here we go. Porter, first one, positive or negative? Okay, are you sure? Are you sure? Why are you sure? What? Yeah, but why are you sure? How do we determine whether something's positive or negative? Hey, everybody else stop, please. How many negatives do you see? Is that even or odd? Is 2 even or odd? That's how you know that it's positive. Second one. Positive or negative? Porter? Are you sure? How are you? Why are you sure? Count. How many negatives? Show me your fingers. Is that odd or even? That's why you're sure. So this isn't like a high-level question. This is literally, can you count negative symbols? And can you tell me whether that number that you just counted is odd or even? You do need to remember, Rowan, Nathan, you do need to remember whether even gives you positive and odd gives you negative. And if that's not committed to memory, that can be, put it on a resource card. All right, Rowan, 2 answers. What do we got? Now that we determined the first one's positive, the second one's negative.
Period. I'd be getting them all right.
All right. Are we good?
Yeah.
All right.
Why am I so smart?
Okay, we do need to write this down, please. Some of the aforementioned properties. Okay, we do need to write this down. Okay, if that's next box.
What is the temperature?
Write this down, please. So the properties that I mentioned that would be on the quiz, that some of you are like, what? When do we talk about that property? We're about to talk about it right now. Here we go. So we already know about the associative property of multiplication, right? The associative property says the order doesn't change. What changes is what the parentheses encompass, right? For instance, here, notice the order goes A, B, C on the left, and still goes A, B, C on the right. Not the order of what you multiply, but the order in its appearance. Notice what is shifted is what the parentheses around. We've already had the associative. Don't write that down. Right? We've already had the commutative. The commutative is when the order does change. Check it out. It goes AB on the left. Then it goes BA on the right. The order changes. These are your additional properties. Box 6 has 3 boxes. 3 boxes. The first one is called the identity property. When you stand in front of a mirror, you see yourself, right? In other words, nothing has changed. We have 2 identity properties, one for addition and one for multiplication. They have funny sounding names. I've already stated them today. So this one is called the identity property of multiplication, sometimes called the multiplicative property of 1. Riley, you need to write this down. This is what's on the quiz tomorrow. Associative, commutative, and these properties right here. So guess what's changing right here? What changes? Nothing. When you multiply by 1, nothing changes. This is called the multiplicative property of 1 or the identity property of multiplication. Okay? This was your first box. There's of 3. It has a twin. Its twin deals with addition. What's the additive identity property? What do you add and nothing changes?
0.
Okay. Before we do that, let's do the multiplicative. I thought I did the additive. I didn't. Sorry. The multiplicative property of 0 states what, Josie?
Anything times 0 is 0.
Write that down. Once again, none of you, yeah, second one, I apologize. I thought I did the additive property. I didn't. No one will make the mistake upon the actual calculation, but sometimes people will forget the name. Make sure this is on your resource card for tomorrow. One of these will be on the quiz. Hey, it's got a multiplication. It's being multiplied by 1. That's the identity property of multiplication. I would also accept the multiplicative property of 1, but most books call it the identity property. And then the last one is the multiplicative property of -1. What happens when we multiply anything times -1?
It becomes it's because the opposite.
It doesn't become negative. It becomes the opposite. Okay? Anything times -1. Oh, wait, it does say negative. No, it says the opposite of A. Because if you start with -2 and multiply by -1, you get a +2. So that's why this A here could be positive or negative. It could be any real number. The one exception is 0. If A is 0, then, well, then we're back to the multiplicative property of 0. Anything times 0 is 0. Those are the 3 properties that you need to recall. Now, these are, the actual math is easy to remember. The names are not easy to remember. So for the 5th and final time for today, these are probably the ones and the associative commutative property you might want to write on a resource card for tomorrow's quiz. The first 3 questions are name the property. One will be associative, one will be commutative, and one will be one of these 3. Shame on you if you get to the quiz tomorrow and you can't remember what the name of that property is. Oh, it's that something with 0. Well, that something with 0 is going to be minus 2 points for you because you couldn't say multiplicative property is 0. One sheet of paper, front and back, whatever you want written on it, on any test or quiz that I give you. There might be when we get to, oh wait, no, this is Algebra 1. There's no, in pre-algebra, there's a couple times where I said, you know, you can have multiple sheets of paper. The ones where you had, we were doing calculation of area, surface area, and volume. But yeah, Algebra 1, it's never like that. All right, we good? All right, let's throw in some variables. All right, remember from our previous rules, we can multiply numbers with numbers, variables with variables. Numbers with numbers, variables with variables. So I can commute this to multiply just the numbers. What two numbers am I going to multiply? -3 and -4, and then times x, y. So I could commute and then put parentheses around the -3, -4. Remember, if I don't do that, it looks like -3 minus 4. It's not -3 minus 4, it's -3 times -4. You're like, is this the distributive property? Well, no, technically it's not. I'm commuting it. I'm moving the order around. Why? Because there's nothing going on here except multiplication. -3 times x times -4 times y. Technically, the -4 times y comes first, and then the -3 times x. Okay, what's a negative times a negative? So what's the final answer? And you're like, well, can I multiply x times y? Yes, you can, as soon as you know what x and y are. I don't know what x and y are, so I leave it as x times y. The basic, this is not rule, this is custom. We write them in alphabetical order. If you have more than one variable, write alphabetical order, x, y. We never mark you wrong. You said 12yx. All right. Is this subtraction or multiplication?
Multiplication.
Algebra 1, I tend to get one or two kids, when they look at this, they see subtraction. Can you see subtraction? I mean, I can see why. It kind of looks like 4x minus 7. But the -7 is inside parentheses. There's nothing right here. This is multiplication. Make sure when you look at that, you don't see subtraction. You see multiplication. Chris, what's the answer? Tell me what to do. I'll do it for you. Tell me what to do. Okay. Is that going to be positive or negative? -28. What do I do with the x?
Stick it on the end.
How many kids are actually going to write this down? Pretty close to 0, right? Right, pretty close to 0. I'm not claiming that you must write this middle step right here, but you darn sure better understand that you know what you're doing. Okay? Yeah, no kid will write this stuff. No teacher will write that step unless I'm teaching it. All right. So when you have lots of stuff going on here, now maybe you want to write some stuff down. Don't try to do this whole thing in your head. Okay? Hey, how many negatives?
2.
Therefore, the answer is what? Positive or negative?
Positive.
I know the answer is positive. Now I just need to do the math. 8 times 11.
88.
So what's the final answer?
88 XYZ.
Are you with me? Okay. So once again, I can still do commutative. Where did this -1 come from? Remember, in front of the z is always a 1. In front of any variable is always a 1. So what's in front of -z? -1. So when I pull the numbers, when I commute the numbers, I'm commuting an 8, a -11, and a -1. So when I pull those off to in front, to the coefficients, right, I'm left with an x, y, z. You're like, well, wasn't z negative? Sure was. -1 times z, -z. Okay? Therefore, the final answer is, you said what?
88 XYZ.
EDQ. All right. All right, box 7. Let's do these together. Here we go. All right, Sophia, the first one, positive or negative? It is negative. Let's see, 5 times 12 is 60. So the final answer is absolutely positively wrong. Because the first question I asked Sophia was, is the answer positive or negative? So for me, what I always do so I don't screw this up, Because what you just did, which is literally called dropping a negative, is that the first question you ask yourself, I put an equal sign and I say, is the answer positive or negative? Well, you agreed that the answer was, I put a negative and now I do my multiplication. This will keep you from dropping a negative. Now I don't need to worry about the negatives, I'm just looking at the numbers. Okay, so the first one is negative 60 AB. Second one, positive or negative? Is there anything to multiply? So what's the answer? This is Algebra 1. We didn't do ones like this in pre-algebra. All right, the last one is the more challenging one, positive or negative. Is this the order you want to multiply them in? Yeah. We like when 10's the last one. So what's the answer? Apparently I like XYZ a lot because I did it multiple times. Are we okay? All right. Do we need to do 3 more?
No, sir.
No.
For those of you that did, there's the answer. And we're done. All right. Quiz tomorrow. What are you not going to forget?
Resource card.
Resource card with your properties. With your properties. You need to go get your lunch. Who's the hot lunch people? Hey, hot lunch people, do not walk down, Rylan, till the bell rings. No. Till the bell rings, then you can. I've been catching some grief from people saying that I've been letting people go a little bit early at lunch. So now you may go. All right, e-learners, if you have any questions, ask me a question.